All right, so here's something new when it comes to functions, because again, we've taken a small look at functions, but specifically linear functions, and we've seen how we can represent them as tables, as just paired numbers, as a graph, as an equation. Okay, but this is a new one. This is called a mapping diagram. And part of the reason why we're learning a mapping diagram now is because you can really see whether something is a function or not in a mapping diagram. Now, here's how you make it. It's called a mapping diagram because think about when you're looking on a map that you're looking at a starting point and a destination, you pretty much just draw an arrow to get you there. Well, a mapping diagram is much the same. So here's what you do. First off, you draw an oval and you just label it your inputs, which typically for us is our values for x. X typically is input. And so what you do here is it says to group the x values in order. So you look at whatever data you've been given. In this particular case, I've been given the data as just raw coordinate pairs. So my x values are 3, 4, and 9. And I'm just going to place them over here in order. So I've got 3, 4, 9, 9. And there's my input values. Okay? And down here it says to ignore any duplicate values. In this case, I didn't have any duplicates. All right, next, you create another oval, leave a little bit of space in between the two ovals, and this will be our location for all the output values. All right, and in the output, of course, is our y values, and we're going to group the y values in order, 4, 5, and 5, but we're going to ignore duplicate values. So in this case, I'm not going to put 4, 5, 5, I'm just going to put 4 and 5. All right, now the reason why a mapping diagram is so useful is because when we connect them with arrows, as the instructions say here, we'll be able to better see whether or not this is a function. So what I want to do is I just want to reestablish the relations that were over here. Well, 3 was paired with 4, so what I'm going to do is I'm just going to draw an arrow from 3 in the input to 4 as the output. The next one was 4, 5. So I draw an arrow from 4 to 5. And the last one was 9, 5. I'm going to draw an arrow from 9 to 5. All right, and so this is called a mapping. Because as you can see here, if I ask myself the question now, is this mapping relation a function? Well, I can more plainly see that each input has been paired with only one output. 3 got paired with 4, 4 got paired with 5, and coincidentally 9 got paired with 5. But do each of these inputs spit out only one output? Yes. Now do 2 of these inputs spit out the same output? Yeah. But that's okay. Okay, as long as we didn't have like 4 and another 4 spitting out a different output. Okay, every input has to spit out one output, which this does. Every input has a single arrow coming out of it to some output. Okay? All right, so let's practice this. You might want to pause the video, but see if you can do this one. Show the data below as a mapping diagram, then determine whether or not it is a function. So go ahead and follow those instructions, maybe pause the video, try to create it yourself, and then start it back up again. Okay, so what this should look like is this once again. Here's my input, and I'm going to find all my values for x. 10, 8, 3, and 10. I'm going to put them in order and no duplicates. So 3 would be first, then 8, then 10, and I don't do the second 10 because it's a duplicate. All right, then I grab another oval, a little bit of space in between, and I label it output. If I look over here, the outputs are -4, 7, 4, -1. And if I put that in order from least to greatest, that would be, let's see, -4 first, then -1, then 4, and then 7. Okay, now finally I pair them back together again. I have to reestablish these different paired relations. So 10 paired with -4, 8 paired with 7, 3 paired with 4, and 10 paired with -1. All right, so then determine whether or not it is a function. Okay, and so this again is why we have mapping diagrams. It's more easily visible when something is or isn't a function. And once again, what we're looking for is, do all the inputs spit out only one output? Well, this input has only one arrow coming out of it. This input has only one arrow coming out of it. But then right here, this input of 10 has two different arrows coming out of it to two different values, which means that that fails our test, and this is not a function. All right, so this is not a function. We can see it easily on the mapping diagram because I've got one of my inputs with two different arrows coming out of it. All right, let's try one last one. Do the same thing. Pause the video, create a mapping diagram for this data, and determine whether or not it is a function. All right, so here's what it should look like once again. Inputs. We've got, what do we got here? 5, 3, 4, 8. So I put those back in order. 3, 4, 5, 8. All right, then over here, output. My values for y. And those would be, what do we got here? Oops. 7, 2, 7, 10. So 2, 7 with a duplicate, and 10. Oops, didn't do that right. All right. All right, now I put my arrows back in. 5 is paired with 7. So from 5 to 7, 3 to 2, 4 to 7, and 8 to 10. All right, and I asked myself the question, is it a function or not? Now this one is a function. Okay, this would be considered a function because again, I can clearly see on a mapping diagram that every input only spits out one output. Every one of these input values only has one arrow coming out of it. Now I've got one output that has two arrows going into it, but that's okay. If you want to think of it in the real world, think of it this way. At hour 4, I'm 7 miles away from my starting location. At hour 5, I'm still 7 miles away from my starting location. And all that means in the story is that between hour 4 and hour 5, I didn't do anything. I just stayed and stopped at a location and didn't move. And in the real world, that works. It's okay. It's functional. Okay? But you can see the use of a mapping diagram specifically for this because all you have to do is map it out. And if you do the mapping diagram right, you can see if something's a function because it'll always have every input having only a single arrow coming out of it. All right, and so that's a bit about mappings.